Okay. Guess we're live, right? Yeah. So, hey guys, whoever's watching, I can actually see right now. Hey guys, welcome to the Docker session. Um, my name's Siddhant, and we're gonna figure out how and what exactly is Docker. So, let's look at the sort of the Google definition first, right? Like, what is Docker? Docker is a set of platform as a service products that use OS level virtualization to deliver software and packages called containers. The service has both free and premium tiers. The software that hosts the containers is called a Docker engine. That was a lot of words, and let's break that down. This is all very complicated and very, I don't know, overwhelming right now, but don't worry, we'll break it down. So, Docker is an OS level virtualization. What does that mean? So, if you go here, virtualization. To understand Docker, we must first understand virtualization. Okay, so virtualization is a technology that you can use to create virtual representations of servers, storage networks, and other physical machines. Virtual software mimics the functions of physical hardware to run multiple virtual machines simultaneously on a single physical machine. So essentially, what you have is one OS that's running on your server, let's say. Now, your server essentially is just this big computer, right? It's just a computer, it's just very big that most websites use to run their websites and other stuff like video games use it to run their websites and whatnot. So now that server has an operating system running on it, right? Like it's one server, so one operating system running on it. Now that operating system needs to be able to run multiple things. Why, you may think that? So now let's say you want to deploy, or you want to run your own website, like your own, that you've written on the server. So let's say you're working on a Windows computer, right? You write all your code on a Windows computer. And now the problem is that the server is running Linux. So let's say it's running some weird version of Linux, like it's running Red Hat Linux or something like that. So now your Windows code might not necessarily work on the Linux machine, right? So what are you going to do about it? You're going to do something called virtualization. You're going to start a virtual machine. Now, what does that all mean? So you're going to make a smaller version of Windows, and you're going to make it run on the server, right? Because all your code essentially is running on Windows. It's using all the Windows functions and all that. And you're just making a smaller version of Windows run on the Linux machine. And what the virtualization sort of system is doing is using something called a hypervisor. So let's say you're using something, a virtualization software, call it VirtualBox. Let's say VirtualBox is a very popular virtual machine handling software where you can essentially, where it has something called a hypervisor. So hypervisor essentially uh, virtualizes and gives like virtual hardware to your OS. So your virtual OS thinks, let's say, that it's a real OS and it's using real hardware, but essentially it's just being virtualized. So whatever's happening on your virtual machine can't really affect the host OS, we call it. So the server on which the virtual machine is running is called a host OS. Host OS, on top of that, there's a hypervisor. And on the hypervisor are running multiple guest OSs. Like you can now run multiple OSs, right? So let's look at this diagram. Let's ignore that one for a sec. So let's look at this diagram. Uh, there's a host OS. On top of that, there's a hypervisor. And on top of that, guest OS 1, guest OS 2, guest OS 3, how many ever guest OSs you want. Because you might want to run multiple instances of your website, right? Like now that one website was enough, one instance of a website was enough to like serve a few hundred people. But now, as your website grows in popularity, you might want to start scaling up. So, scaling up essentially means you want to serve more and more users. So, you're going to spin up more instances of the website that you're running in order to sort of serve more users, right? Like a few couple hundred will go to app one, few couple will go to app two, app three, and so on. That's how you scale up in order to serve more users. So that's virtualization, and that's great. Um, so then, why are we talking about Docker, right? Like, if virtualization works, then and Docker is supposed to be a replacement for virtualization, then what's the point? So Docker works a little differently, and I mean, you can sort of call it analogous, but here's how Docker works. Docker, as you can see in this diagram here, there is a host OS, there is a Docker engine instead of the hypervisor, and where's the guest OS? It's just your app running inside a container. Now, I'll explain container in just a minute. So, how Docker is working is that it's completely cutting out the OS part. So, let's remember. So, I told you like how Windows, a million but now happens that as you keep adding more Windows, major Windows in the server, each Windows is taking a lot of resources. Like each Windows has like specific things, right? Like every single version of Windows, let's say, is coming with stuff that you might not need, right? Like normal production doesn't really come with this, but like let's say each Windows is coming with its own Microsoft suite, and like your app does not need Microsoft suite. So why is it even there? It's just there consuming resources for no reason. Like an entire operating system is being just duplicated for no reason. So Docker sorts of cuts that part out. Docker instead takes this whole thing and runs it as a Docker engine. So Docker essentially virtualizes the operating system layer itself, and then it's only running this part. So bins and libs are essentially files and drivers and all that stuff that's necessary for the app to run. But but and Docker is running those things in containers. So now containers is a very important part when it comes to Docker. So container essentially is a packaged version of only your app and what your app depends upon, not the whole OS, just what you need. So that sort of makes Docker different. It's not running the whole OS, it's only running the lightweight package of whatever code you've written. So we'll look at code examples later, but essentially, how is Docker different, right? Uh, so this is virtualization. We're virtualizing your whole app. whole operating system. In Docker, you have containerization, where you're only having containers for your code, for the website that you've written, whatever app or thing you've written for your server. So modern day servers, they use containers because they're much more lightweight. They're cutting out that whole OS part, and only the Docker engine is orchestrating, is a technical term for it, I guess. Orchestrating the whole uh, container part. Like they're maintaining all the containers. So now let's come to isolation, right? What does that mean? So isolation essentially means that since in virtualization, it's different OSs, right? This first OS cannot communicate with the second OS, and second OS can't communicate with third OS because they're literally separate OSs. They don't know that they are being virtualized. I mean, technically they do, but that's all I can remember. For our intents and purposes, they do not share anything except for the host OS hardware that the hypervisor is controlling for them. Like the hypervisor essentially like allocates, okay, 2 GB of RAM here, 2 GB of RAM here, 2 GB here, and that's pretty much it. And then it's just running these virtual machines. Docker engine, on the other hand, is running these containers, and you can also define like how much resource it can allocate, but it's a lot more transparent. Like these containers can actually communicate with the other containers, which is very helpful when we want to run like things called microservices. We'll see this here. So microservices, again, I'll come to that in a sec. Again, resource efficiency. Like you're virtualizing an entire operating system, right? So obviously there's a lot more resource usage, whereas in Docker you just have just the container running, which makes it a lot easier. Of course, start time. You remember how long it used to take your old computer to boot up, right? Now imagine just miniature version of that, like a whole operating system booting. That's going to take a lot of time. So, and then containers are very lightweight. They're very packaged up, so they take lesser time, and then it's easier. If your server goes down, then to instantiate it back up, it's going to take very little time compared to the virtual machine stuff. And then, of course, use cases, multiple applications with diverse operating systems. So let's say um, I, Siddhant, I wrote code in my Windows computer, even though I don't really like Windows. I wrote in Windows. And now my friend Dinesh, he writes code on his Gen 2 Linux. Okay. Now, the Gen 2 Linux virtual machine will run as a guest OS on the host OS, and then the Windows version will run as an app. And it's separate, it's diverse, whatever. Containers, on the other hand, sort of do the same function, but you're only packaging up the code. So wherever you run it, it's gonna run. So the thing about Docker is, it's called operating system agnostic. What does that mean? So whatever operating system you are running on, if you have the Docker image, I'll explain that also in a second. Docker image is also very important. So as long as you have the Docker image, you can run a container based on that image on any operating system that's running Docker, that has the Docker service installed on it. So what is an image, right? So once you start, okay, so this is all virtualization, containerization, and we'll look at this in a sec. So what is an image now? So let's say you want to Dockerize your project, okay? You wrote code, okay? Let's say you wrote a beautiful API, okay? If you guys don't know API, then well, API is just something you can use to communicate with your databases, and like it's essentially the whole backend of a website. Like an API communicates with the front end and the back end, and that's how it works. So let's say you wrote an API, right? And the API works brilliantly on your machine, on your beautiful Windows machine. It works great. But now you want to ship it. You want to deploy it on a server. How are you going to do that? You're going to Dockerize it, right? You're going to make the code that you wrote, the ability to run, give it the ability to run on containers as containers. So what are you going to do? You're going to Dockerize it. So to Dockerize it, you need to convert it to an image. And that image can essentially be used as a blueprint to spin up as many containers as you want. So here we saw that one image is running app 1 and app 2 and stuff like that. So if I want multiple instances of one container, let's say my code that I wrote for the API, all I need to do is build an image. Um, don't worry about how you can build an image. We'll see that in about, I don't know how much time it will take. We'll just look at it real quick later. So you have to build an image, and then once you build the image, you can make as many containers as you want. So the containers are being built off the contents of the image. So I wrote API, right? I converted to an image. I called it API image. And then I put it on something called Docker Hub. Docker Hub is a container registry. You can figure that stuff out later. I'll show it you later. And Docker Hub essentially holds all these images. So now, let's say Dinesh wants to look at my API now, and Dinesh wants to run my API on his machine. So Dinesh will go to Docker Hub. He will pull my API image, and then he can just run containers off that. Like, because Dinesh can't really change anything on my image, he can only change my code and then rebuild that. So it's sort of helpful in a way, like he doesn't break anything, and it always runs on his operating system or his machine, wherever it wants. So essentially, why Docker was introduced is to fix this whole problem of, oh, it runs on my machine, it doesn't run on your machine. So the good people who made Docker, they just figured that, okay, screw it, let's just make a tool that will work anywhere, that will help people run their code anywhere. So, and then here comes Docker, and it does everything that I've just explained. It's a sort of drop-in replacement for virtual machines because it's a lot lighter and it's so much better, guys. Depending on your use case, of course, but for me, I just love Docker. So now, actually, let's just get our hands dirty with some commands, some code. So I don't know how many of you were in CBSE, but we had to learn SQL, right? I was in CBSE with computer science, so we had to learn SQL. And to learn SQL, we had to like download MySQL or like Postgres in some cases, and then we had to install it on our machines. And like some computers were like super slow, so MySQL wouldn't run properly, or like there was some issue with the operating system. Like Mac people had to do something else, Windows people had to do something else, Linux people were chilling because they're good with computers. But so there were so many issues just because the operating system were different. Like our computer teacher, she would explain the installation process just for Windows, but then the Mac OS people would be like, oh ma'am, it's not working on my system because you only explained for Windows, how do I install it? And the teacher would have to go specifically to them and then explain it to them, and it was a whole problem. So what we can do, actually, it's so much simpler that we don't even have to install a database on our server, on our computer. What we can do is pull the image of Postgres. So Postgres is a popular database software, if you guys didn't know. We can pull the image, the blueprint sort of Postgres from Docker Hub or whatever, and we can just run a container, and then we can just like exec or like go into the container and run SQL in the container. Like you've had no use for installing Postgres if you just want to learn Postgres SQL. So let's actually open up a command line. So let's say this is just a sanity check for me. Never mind. So if you guys haven't installed Docker already, you can go to docker.com. Docker.com. Yeah. So actually, just Google it. Yes, Docker installation. Docker installation. So how do you install the Docker engine, right? Like, how do you install this? this green thing. So there are multiple ways you can do this. On Linux, you just have to literally just one command sudo apt install Docker. It'll ask for my password, and that's it. I've already installed it, obviously. So, but that's how it'll work on Linux. I recommend trying out Linux at least once in a while. You can just go to the website and download Docker yourself, and that's that. So for Windows, you will have this. On Windows, there's another good thing that you will actually have a GUI, Docker GUI for Windows. Like if you look at images, this is what it'll look like, right? Like all your images are just right here. Like this is Jenkins. There's a Minecraft image. Oh, another fun thing for the gamers, I guess. You can run a Minecraft image on your machine itself. So, like, if you want to play with your friends, um, you can just start a Minecraft server on your computer as a Docker container, and it'll work out fantastic. And then you can like deploy it on a server, like an AWS server or like an Azure server, and it's so convenient. Guys. Docker, love it. Uh, that's why we're here. Okay, so anyways, this is how you install it. You can just go through this. I'll add it later, or like I'll put it in the GitHub repo once I upload all the code. Once we write all the code. Uh, one sec. Uh-huh. Sorry for an interruption. Yeah. So, anyways, this is how you install stuff. You can just literally just Google it, guys. It's not that hard. Yeah. Okay. So coming back now, let's actually look at the commands. So if you do Docker on the command line, I'm using Ubuntu. If you guys are using Windows or Mac OS, it should be pretty much the same thing. I think Windows also you get a command line and it's gonna be the exact same. So all the commands that you're gonna use for Docker, they're all listed out here. Like most of the things that you might need, it's all there. Like if I do Docker -h, it's just gonna give me the help. Like it's the same thing. Okay. Anyways, so now we want the image. What we're here to do is we're gonna run SQL on a container, right? An instance of Postgres. So Docker pull Postgres, right? What's it gonna do? It's gonna pull an image from the container registry called Docker Hub. Docker Hub is where most people put all their images. Postgres is a public image, so anyone can download it. And it's just gonna download. Again, so I already have Postgres on my machine, the image. So it's gonna get me the latest image. And then we can just like run Postgres. So now we want to start a container of Postgres. How do we do that? So if you want to run any image, let's say I have an image called Docker run, and then you just literally put the image name here. So I don't have an image called image name, but if I did, I'd just like if I had written API name, API image, as you might remember, this is literally how I would do it to run a container. Anyways, so now Docker Postgres. So I've already tested this out for you guys and Postgres. I'm sorry. Sudo. The sudo part is irrelevant, you guys. Docker. And this is the command. So now there's a bunch of stuff here. You don't have to really worry about it right now. But essentially, what this is doing is it's going to run. I'm going to remove the sudo part. Yeah. Essentially, what it's going to do here is it's going to run a container. All you have to do is look at this part. Okay. Docker run Postgres. So I'm gonna actually explain what it's doing here. So Postgres ka password is just admin. Like I'm telling the container that once you start the Postgres ka container, the database that you start, it's going to have a password known as, once you want to log into Postgres, the password is going to be admin. So if you do this, if you hit enter, whoops. Uh, oh shit. Okay, my bad. So okay, what's happening here is there's something already running on port 5432. So I'll explain ports also in a bit. Ports, it's very simple. So this is a port, okay? 5432 is a port. Now, ports are essentially channels on your machine. Like every computer has a port, has a bunch of ports on it. And on each of those ports is a specific service running. Now, each of those service, so let's say HTTP, it's a service. So like, let's say you want to start an HTTP server. That service specifically runs on port number 80. Or like if you want to do something called SSH, Secure Shell Protocol, that's running on port 22, and then 443 is for HTTPS and blah, blah, blah. So essentially channels for specific services, that's running on different ports. So Postgres is currently running on port 5432. And let's actually see Docker. If I'm actually running. Oh, okay. So I was already running a port, a container, uh, a day ago of Postgres. It's called friendly, whatever. Like Docker automatically gives names for this. So that's fine. So now we want to run. So yeah, if you want to stop a Docker container, we can Docker, excuse me, Docker stop, and then we can just write the name friendly, whatever, and it'll stop the container. So I don't want to stop it right now. I just want to show you guys like this container is running currently. It was created 23 hours ago and currently is running on port 5432. Now let's actually Docker. Yeah. So now this is a command I wrote earlier. So I'll break this down as well. So, okay, we'll write the name friendly underscore L Bakaya. In about 2 minutes, once this is successful, I'll actually go to the comments and look at it, and we'll see. Yeah. Whoops. Oh, that's weird. Huh. Yes. Stop. E610. Okay. Okay. So now we've okay, that I'll explain that later. That was just a little error. Huh. Okay. Docker PS. Now we have a new container. I deleted that old container. I just created this new container 9 seconds ago, and it's called Keen Fawn. I don't know why and how Docker comes up with their names. Like you can define your own name, but no, I'm too lazy. So now let's actually exec into this. So what I'm gonna do here is, and then just okay, fantastic. Yeah, okay, thank God. So now we are in Postgres. As you can see, PSQL is a handler for running commands, SQL commands. So I can do whatever I want right now here. And this is running on a Postgres container. I haven't installed Postgres on my system. This is all happening inside that little package of Postgres that Docker built, that Docker started, not built, started from the image of Postgres. I'm not sure if you truly appreciate how cool this is, because you didn't have to install all those Postgres software, like install, reinstall, and then delete, all that stuff. That takes so much time. First of all, Postgres is so hard to install on some machines because, first of all, it's too heavy. So on hostel Wi-Fi, it's just not going to install. Second, you're going to have Docker installed anyways because you're going to use it for your other projects. So if you're learning SQL, just might as well do it in a container because it's going to work the exact same way. So let's actually, oh God, I can't remember anything. Slash D. Okay, did not find any. Okay, we have to create a database, I guess. Create database. Let's just call it hello, I guess. Okay, and we've created a database. And now if we do slash D, oh, never mind. So now use, what did we just call it? We called it hello, right? I have goldfish memory. Use hello. Okay, never mind. That's okay. My SQL skills are not the point of question here. What I'm trying to show you is that we started an SQL container, a Postgres container, and we just ran SQL on it, which means that the container is running. The container is doing exactly what you wanted to do, which is run SQL. And we've done that. We've done that. And now we can just like leave this because it's getting embarrassing how little I remember SQL and Postgres. So, anyways, now we're back to our thing. And if I want, so Docker PS, I don't know, I can't remember if I explained this to you. Docker PS will essentially show you all the all the containers that are currently running on your system. So now if I want to stop a container from running on my system, I can just do Docker stop, and then I can select this. And it'll stop. So now if I do Docker PS, no containers are running. Of course, because I stopped that container. And life goes on. We can start up a new container. It's not that difficult. Docker PS, Docker PS. And now the new container is called Blissful Heisenberg. Oh, I don't know how many of you watch Breaking Bad, but there it is. So now you have a new container. And this is essentially what I wanted to show. Okay, you pulled an image from Docker Hub and you ran SQL on the Docker container. You just started a Docker container using Postgres, the image of Postgres, and then voila, you ran SQL in the container. So I could have started as many containers as I want. So let's actually do that. So now, I don't know if this is, you know what? Let's try it for the hell of it. Yeah. So now, Docker exec dash p. I don't know if it'll work or not. Let's see. What is it? Docker. Yes. Okay. So the new container, you can see, the new container is mapped from port, the host port, my machine's port 5422, and it's mapped to 5432. That's sort of the feature I wanted to show you. Like, let's say you wrote code. You know what? Actually, this will come in later when I show you the code. Remember this for now, that you can run multiple containers. You can start as many containers as you want, as long as the ports don't clash. So now what do you call it? Right. Copy. This is a very ugly way of doing it, but yeah, same thing. So now I have two Docker containers and they're both running at the same time. And yeah, that's not bad, right? Like, okay, we'll just quit out of this. There's a command for like stopping all the containers. I can't remember right now. Forget it. We don't need it. Okay, anyways. So yeah, sorry. There we have it. So essentially what we did was we pulled a container, we pulled an image, we ran a container based on it, and then we ran SQL. So next time you want to learn SQL, maybe learn Docker before that, or do exactly what I just did. So okay, I'm probably gonna go look at the chat for a bit. Okay, cool, fantastic. Let's go. Yeah. So now, what we should do is we should write our own code, right? So let's go here. Oops. Excuse me. Huh. So, okay. So here's some basic Flask API code I've written. Okay. Ignore all this. This was just prep for me. Here's some basic Flask that I've written here. Uh, so Flask is essentially a Python library, Python framework, you can say, that helps you write APIs. If you don't remember from what I just explained, APIs help you. Um, APIs are essentially your entire backend. It controls the database. It controls what's the flow of data between the front end. Front end is essentially what the user sees, and back end is what's running on the servers. So this Flask API is what's gonna yeah. So this Flask API is what's gonna run on a server. So once you deploy this, deploy essentially just make it run on the server. Um, this is a code that's going to be exposed to the millions of users that come to your website. Right. So cool. So yeah. So I'll explain this code in brief because we're in a Docker session. We're not really for a backend session. So Flask, if you've done Python in your first sem, or if you're doing Python currently, you might recognize the syntax. Import Flask uses importing the library, import request and JSONify. We actually, yeah, we actually don't need this file. I don't know what happened. Yeah. Okay. And now you've initialized your Flask object. Now this is just some syntax. So essentially what is happening here is that on the website's homepage, sort of, the first URL, if you make a get request, again, this is all technical mumbo jumbo for backend. You don't really need to know it right now. But yeah, on the homepage, home URL, it will display once you make a get request on this endpoint, as you call it, it will display this bunch of code, this bunch of HTML. So, and then we run this app. This 10th line is essentially run. You run it on port 5000, debug true, that's just a Flask thing, and host 000, that's also a Flask thing. You don't really have to worry about that right now. You can explore this further. You can go to Flask's documentation. I think Flask documentation. And you can just read up on Flask. It's very convenient. If you're getting into backend and if you only know Python, then Flask is a fantastic way for you to begin. Anyways, so now let's get into actually running this. So if we run this, Python and just app.py, right? Because all this code is in app.py. Yeah, if you run it, please run. Oh, fantastic, it runs. I am amazing. And now our server, as you can see, serving Flask app, debug mode on, as you saw here, running on all addresses, running on HTTP. So this server code that we've just written is running on this address. So if you just copy this address, copy, and then if we go to our browser and if we paste it here, voila, that's what it's doing. We are showing this. So if I change this, hello, I am doing wonderfully today. Let's see. Good vibes, right? So now if you just restart, okay, and then if you just, okay, and that's what it's serving, right? And this is fantastic. This means that we've just written server code. Like my browser made a request to this address, and then we got this response back. And fantastic. So where do we go from here? Now, I wrote this on Linux, by the way. I'm running Linux, right? Now I want to run this on a server, and let's say that server, for some god awful reason, is running Windows. So what do we do now? We have to Dockerize this, right? This is the fun part. So let's start working on the Docker thing. Huh. So to Dockerize something, we need something called a Docker file. As you can see here, that's how you name it. Okay. We just need something called Docker file. Docker file essentially is a configuration file, which says that okay, this is how you can convert whatever code you've taken into an image that you can use to run later. So here's what our Docker image is doing. I'll go through it line by line. Okay. This is very small code, by the way, so this shouldn't be that hard to understand. Yeah, just 6 lines of code. It could be shorter, I think, but let's not try that. So from Python colon latest. So if you remember from the Postgres thing that we just did, it pulled an image, right? And it had the latest version of that image. So exact same thing is happening here. It's using the Python image that's currently on my system, or it will pull it later depending on if it's there or not. So the Python colon latest is on my system, and then it's the latest version. Okay, and then work directory slash app. That means in when you make the container, inside the container, it will have a directory where all my code will be. So the work directory is called slash app, and then next you copy the requirements.txt to file called requirements.txt inside the container. So requirements.txt again. Requirements.txt is a very simple file. We'll just make one right now. So pip freeze. Don't worry about all these commands. I'll put in the GitHub repo later, and you guys can see it. Pip freeze. Excuse me. Requirements.txt, and it's just made a requirements.txt. Now all it has is the names of the dependency, the names of the libraries that I'm gonna use to run all this code, right? Like I need Flask, so it's got Flask listed out. So once we sort of copy it all into our container, the containers also needs like all the libraries, right? So it's just gonna copy all the list of the dependencies, libraries, and yeah, then it's gonna install all the libraries from there. So pip install -r requirements.txt. Fantastic. So the requirements.txt, all the dependencies have been installed. Now you're gonna copy all your code. So why am I installing libraries first and then I'm running all my code? Why couldn't I just have copied all my libraries? Uh, this is just sort of an optimization step because Docker does something called caching. Like if nothing's changed, then it's gonna cache all these layers. This is a very in-depth stuff. Essentially, what this is just best practice. So when you Dockerize your own app, you're gonna want to first copy all your dependencies and install them, and then you're gonna have to copy your code. Cool, works. So now, last, we're going to simulate what happened here. Python 3, what happened here, how I just ran my code is going to happen here. Fantastic. So now, excuse me. Yeah, so now we want to run our code. We want to build our image for this API that we've just written. So how do we do that? So Docker build, and I don't know what you guys want to name it. I just want to name it bro. So bro, and then where is the configuration file? Dot. So dot in Linux or like in file paths dot means in this directory. The Docker file, that's the sort of configuration, that the map that is being used to make the Docker image, that's where it lives. So that's essentially what the command is doing. So Docker build an image called bro, and the instructions that you need to build bro is in the directory that you're currently in. Whoops. Oh. Docker build. Have I done this before? Oh, my bad. So Docker T. I'm sorry, guys. So Docker -T is also required. So let's rename this. So Docker -T. This is just a command line argument. That means the tag that you need. So -t bruh. And then now we are building the image. There's also we'll go into all of this in a sec. But yeah, so what has happened just now? Let's go through this. Okay, what has just happened? So internal load docker ignore. Docker ignore is just something I need for ignoring the unwanted stuff. We'll look at that later. So transferring context, load build definition from Docker file, right? Build definition. That means how to build this image. We got it from Docker file. Okay. Transferring Docker file to the container, to the image building thing. I'm sorry, I forgot the word for it. From Docker, it goes through it line by line, right? 1 out of 5, and then 2 out of 5 work to the app, 3 out of 5, 4 out of 5, and 5 out of 5. It's completed all the steps. These 5 steps. Excuse me. Fantastic. So now we want to run this image. How do we do that? Docker run, and then whoops, excuse me, run bruh. Voila. So now what's happening? So we had an image. So remember last time we did Docker on Postgres? This time we have our own image that we just made. And now we're just running the Docker image from there. So this is, I'm hoping it's going to work the exact same way. Yeah, there it is. Yeah, so it's going to work the exact same way. If we use this, open, yeah. So now, instead of the code, the app.py, running from my own machine, it's running from a Docker container. This is huge. So now I can actually spin up as many containers as I want. So here, Docker run, bruh. And then now, instead of 5,000, like I was running on port 5,000, right? But now port 5,000 is already taken by this container. Like if I do, oops, yeah, if I do Docker PS, you can see that the image bruh and a container named, oh my god, quizzical capizza is running on, it's not showing me the port, but essentially yeah, screw it. So it is running on port 5,000. Like if I try to run my Python, if I try to run my Python code, Python app.py, oh, it runs as well. Never mind. So, but now we want to run another container bruh. Oh, whoops, excuse me. Docker run dash t bruh. No. Oh my god, what am I doing? Yeah, Docker bruh. And it's running on another container. So now if you do Docker PS, it's running 2 containers called thirsty Bhaskara. 2 containers are now running. So if I had like a request on this, it's probably given me another address, right? Yeah. So on different addresses, it's running Docker, right? Localhost. Okay, that one's not working. Never mind. But yeah, so it's given me 2 addresses: 172.18.0.4, 172.18.0.5. It's running 2 containers, 2 different addresses, which we can later map into whatever. And then we can, but the proof of concept is that now we're running 2 containers, both different services, but the same code, same exact code. So now we can just stop Docker, stop. Actually, I should do it here. Docker, stop. Whoop, whoop. There we go. Docker, stop. What is that called? Quizzical paste. There we go. So now those containers have been killed off. I mean, they're not killed off, they're just not running anymore. Anyways, so there we have our code. We have successfully Dockerized our code. So actually, there's a tool on VS Code where you can see all your images and stuff. So we had Bruh Web and all that. We just ran Bruh, right? Thirsty Bhaskar and Quizzical Kapitsa. We just ran that and it just exited a minute ago. Like you can see all your images on VS Code. This is a fantastic tool. I think it's called like Docker. It's just called Docker. Uh, Please load fast. Yeah, see, it's called Docker. You can install it on VS Code, and instead of like using commands and stuff, you can just like look at it through here. So that's cool and all. But now, let's say you want to run the excuse me. Let's say you want to run the Docker container of Postgres. So like let's now Postgres container and your apps container, your APIs container, both need to be running on the server, right? Because you can't use the installed Postgres installation on the server because that might have different configurations and who will install it on the server and all that. So now you need a container of Postgres and you need a container of your API. And your API ka container depends upon Postgres container. So how do we do that now? So here, I'm just gonna just comment on this. Yeah, screw it. So now what I've done actually is I've written a separate, yeah. So now I've written a separate code base that has a bunch of other stuff. Okay, this is a lot bigger. It's gonna take me a lot of time to explain, but this is essentially to introduce something called Compose, Docker Compose. So as I explained, API container and database ka container, they both need to be running, and API container depends upon the, what do you call it, Postgres container, the database container. So how do we make that happen? So let's go to our code. This is just the API, but like on steroids. So all of this code, all I've done is I've made an API that interacts with a database now. All it does is interact with a table called names. The names table, I've actually written all the SQL also using SQL Alchemy. This is all code that's available on GitHub in some time. You can go to the GDSC GitHub and you can look at it. But yeah, so create a table called names. This is the function that creates a table. I'll you don't need to know all this. This is gonna take way too much time if I start explaining the API and how it works. But essentially, what this code does. Why is this red button? Yeah, whatever. I'm getting distracted. Yeah, so what this code does is, okay, so it creates a table called names on Postgres, and then it just has two columns, ID and name. And now what you can do is I've made something called a CRUD API, CRUD. So a create, read, update, delete API. So that's exactly what it does. It creates. So here we can create a new name using the insert name function. It'll create a new name on the table, on the database. It can retrieve a name by ID. It can, it can update a name and it can delete a name. So pretty simple stuff. It's pretty much like around 70 lines of code, I'd say. And it's good stuff. So now this code, this app.py, this version of app.py depends upon the Postgres. Okay, what's going on here? Okay, VS Code is just being stupid. Never mind. So now, this app.py that we have just dockerized. It's the same Docker file, by the way, like because the app hasn't really changed. We just added one more file, but all the files are being copied anyways. Go away. Yeah, all the files are being copied anyways, so I'll have to fix that later. Okay, anyways, so now what do? Well, we have something called compose. Now, compose is another configuration to basically handle multiple containers, right? Now, how do you do that? So we have to define something called services. Version, you can just like leave that. It's just for developmental purposes. Services, you have to define services. So whatever service, so like your API service and your database service, right? So here's your DB service. It uses the Postgres image that we saw earlier, right? That we logged into, that we exec into, and then we ran SQL on it. And then uh, this is all the Postgres sort of environment variables. Again, if you've worked with databases, you'll know. You saw this part earlier itself. You saw admin as the Postgres password for the container to log in. Okay, and this is volumes. So volumes is important when you start working with databases because this is essentially persistence. Whatever data you make is going to get stored on the volume. And then you have the web service that you have written. It builds dot. So I think I explained dot to you before. It builds the Docker file, whatever web service you just made, and it runs on port 5000, 5000. That means your host machine and the container's host machine. And then you've just listed out the volume, the data volume here. Okay, cool. So now we need to build this. So what do we do for this? We do docker dash compose build, and there we go. It's built it, and now we have to run all of this. Docker dash compose up, and it's gonna start all these services. So if this is working, I hope to God it is. Yeah. So now our version of the Docker file of the app, this version of the app has been containerized, and now multiple containers are running. So as you can see, the DB container is running. The DB container is running first because obviously the web service depends upon the DB service. So that's why it's running first. And then the web service starts. So that's cool. That Docker Compose sort of automatically figures out what depends on what, and that's how it begins all the containers. Right. So, okay. It's been a while. So I'll explain all the stuff that's going on right now. So this is what it does. The home page essentially shows um, an HTML file. You can get all this code later and then build it yourself. But essentially what this database does, I'll show it to you on Postman. So let's say you want to get all the names. So automatically I had a name in the persistence called Tony Stark, right? Now I want to make a new name. Let's call this new name Siddharth Srivastava, as you can see here. And then you run it, and then you get a response back. So now if you get names again, you send a GET request. Siddharth Srivastava has been created. Fantastic. And then if you want to update the name, let's just call it Sid Sarsad, the ID. So essentially Tony Stark is going to get updated. Let's call it Sid Sarsad. And get names, and ID1 has been changed to Sid Sarsad. Fantastic. And then if you just want to delete, let's say delete ID9 and send. Success. And now ID9 from Siddharth Srivastava previously, and now it's gone. So that's all it does. It's working on the database. You can see all the requests that's coming into the API. And fantastic, cool, it's working. Whew, that was a lot of stuff. Okay, you need to go through all this code if you want to understand how the API works, because this is essentially backend development at its finest. Like you make CRUD APIs, you interact with the database, and then you send the response back. So this is our response. This is our result. And now, yeah, so you might start running into some troubles with this whole process. I mean, as we saw, let me just close this out. And close that out. Okay, so this is just a page that shows all the routes. Like what we just saw is just a documentation. I thought it'll be easier for me and for you to understand. So we saw all this. So now let's just troubleshoot some stuff. So yeah, so if your container is not starting, then you need to check the container logs as we looked at before. Like you have to see, right, Docker PS or like Docker logs is another command that you can. I'm gonna close this out by the way. Okay. So Docker logs, you can see the container, what's happening in the container. Or like port and network issues. I think we saw that also earlier, right? Like the Postgres container wasn't working because there was already something running on it. So that's what happened, right? A port conflict happened and then it wasn't running, but then I stopped that container and it started running again. So fantastic. And image not found, we didn't really have that problem because all the images were already installed. But like manually pulling the Docker pull, manually pulling the image, and that works out for you. So all this stuff is already available on the documentation. I'm just sort of giving you a hands-on approach. Okay, so that's about concluding what we've just done. Okay, what we did was I explained to you what virtualization was. Uh, yeah, I explained to you what Docker, what virtualization was. I explained what Docker is. Why do we need to use Docker? How is it better from virtualization? You can do whatever the hell you want on Docker. Like you can run SQL, you can like treat it as the app itself. It's just a lightweight version of it because it's not working on a virtual machine. It's working on the Docker engine, right? So now, where do we go from there, right? We saw Docker Compose. Docker Compose is a lot bigger. I've only given you a glimpse because let's say not just database, but you want like a file handler, and like this web service is not the only thing that that your website's gonna need, right? It's gonna need like another file handling server. It's gonna need something called a cache. It's gonna need a message queue and blah blah blah. A lot of other stuff that if you get into backend, which I recommend you should, if that's a thing, uh, you should know Docker because again, if you want to work for like big websites, then they're using Docker. Anyways, so that about concludes our session on Docker. And all of this stuff is important and all, but we have our facts coming, right? I don't know about the other people, but we have our facts coming, and some of it can be sort of challenging for you mentally. Like it's pretty mentally taxing. So we'll come to question later, but I'd like to talk about CASA. So CASA, the National Center on Addiction and Substance Abuse. It is a very important organization. It plays a pivotal role in educating and supporting individuals, particularly in high stress environments like colleges. Like as exams are coming, some unfortunately might succumb to substance abuse, and CASA is trying to sort of mitigate that and help with that. So where the risk of substance abuse can be heightened, right? High stress, so substance abuse is pretty common, unfortunately. Recognizing the link between stress, mental health, and substance abuse, CASA offers strategies and resources for managing stress in healthy ways, which is especially relevant for students in demanding fields. Like the current field we're in, engineering, it can be pretty stressful. So CASA is doing a great job at sort of helping us out with our mental health, while providing accurate information about risks and effects of drug use, helping dispel myths and misconceptions. They emphasize the importance of having a strong support system, whether it's through counseling, peer support groups, or online resources. These networks are vital for prevention, intervention, and recovery. Again, super important stuff. So, as individuals passionate about engineering and technology, we often face unique pressures and challenges embracing CASA's so pressures and challenges. Embracing CASA's mission is not just about preventing drug abuse, it's about nurturing a balanced lifestyle where we prioritize our mental and physical health as much as our technological pursuits. This balance is key to sustaining our creativity, innovation, and productivity in the long run. In conclusion, while we continue to explore and excel in the realm of technology here at GDSC, let's also commit to being informed, supportive, and health conscious members of our community. The principles of CASA are not just guidelines, they're essential components to to a successful and a balanced life. Okay, thank you very much. I think we can move on to questions. Yeah, give me a moment. Okay. So let's look at the. I need to open the stream. You'd think I'd be good at tech by now, but here we are. Oh, huh. So I don't know. Okay, no questions so far. Okay. Okay then. If there's no questions, I think we can end the session. It's been pretty great. Uh, yeah. Okay. I kind of missed all this stuff. Oh, seniors are here. Fantastic. Yeah. Okay. Cool. 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 No doubt. All right then. Um, we can end this. Yeah.